Okay, so as people are filling in, let's do a little warm up. Okay. All right, guys, good afternoon, everyone. So here's a quick little warm up as you guys are getting settled in. These are just 2 questions that hopefully you feel comfortable to do from last time. So try these out. Message me in chat when you, if you're done and you got your answer. And if you need a little extra help, also you can message me privately and I can give you a tip. Emily asked a good question. How do you find the intercept? I don't know if last time I showed you that approach. So maybe um, I'll just mention it now and then we can go over it again carefully. One approach that I didn't show you last time, I think we just didn't have time, is you first find the slope. So you can find the slope using the picture, do y2 minus y1 over x2 minus x1. So you find the slope. And then you have, once you find the slope, if you remember, that's y equals mx plus b. So you can, the steps are, you can find the slope. And then that's going to be some number. And then plug in any point. Plug in either the first point, plug in either point. and then 3 is solve for b. So I didn't go over this last time, but so only a handful of people so far got the answer. So take your time. And those of you who just entered, here's just some warm-up problems that, and I'll try to start the class usually with a little bit of warm-up, like the first 10 minutes. And just a poll here, and you guys can message me privately, but would you be interested in having a links to the recording without, it'll only be my video and the the whiteboard. If there's any objections to it, let me know. But I was thinking, because I know some students maybe sometimes can't make the class, so I can post a link. It's probably most helpful to just ask a friend what you went over and talk to a friend, because sometimes just watching a recording could be hard to follow. But if you're uncomfortable with that, let me know. But if I have your permission, I can share a link. But the links, because I don't have unlimited storage, the links will eventually expire. So this could be good to catch up. I think I'll be able to have about 5 or 10 lessons stored. Okay. Looks like people are positive. If for some reason you're uncomfortable with it, just let me know. Yeah, Allison, you can message me your answers, and this way I'll write back to you and see, give you some feedback. Just hang out. After you solve for B, you can. After you solve for the variable for B, you can just put it all together in one equation. And okay, let me see. Allison. Okay. Awesome. Anyone willing to volunteer? And no pressure at all. Anyone want to volunteer for part A for the first warm up?
I can go.
Go for it. Thank you.
Okay, wait, so I just do like, do I do the whole problem or just like the first step?
Oh yeah, go for the whole for part A with the exponents. Go for the whole thing.
Okay, so what I did was I wrote it out and then I did 2 to, on the bottom was 2 to the negative second, x to the negative second, and then
Okay.
on top was still 2x to the negative third, but then I moved the 2 to the negative to the top, which got me 2 to the third, and then I moved the x to the negative third down to the bottom and I added it to the negative second one, and I got 2 to the third over x equals 8 over x.
Nice. Perfect. Thank you. Allison, that was great. So yeah, this would be 2 to the third because we know that's dividing by 1/4, which means you bring the 2 squared to the numerator. And what Allison did here was really nice. She moved down the x to the third to the bottom, and you could also just move that. I kind of moved the x squared to the top because I like to just move things around and only deal with positive exponents. But I like this approach as well. So x to the third times x to the negative 2, and then this simplifies as 2 to the third all over x, which is just 8 over x. There's many ways to manipulate these. So make sure you just kind of, like now that you've seen the answer, um, uh, especially if you do some practice, try to stare at these a little bit just to see how you could get comfortable to maybe manipulate this ahead of time without necessarily writing everything out. Like, for example, I could see I kind of anticipate this whole thing. Like it helps me to see this entire thing, 2 copies of this being moved to the numerator, and that would be 4x squared in the numerator. And then I see the term, and I'm careful with the parentheses. There's no parentheses around the 2x. So I see this term. I know that 3 of these are going to be moved to the denominator. And so then I can simplify from there. Very good. Are there any questions on the first one? I would say about like 50% of students, or maybe 40% of students, got it right on the first try. So don't worry if you didn't quite catch it. We'll definitely keep doing practice questions like these as we move forward, and hopefully in the homework that you'll see them. Anyone want to volunteer how they did the equation of the line?
I can.
Yeah, thank you, Amy.
So first what I did is I labeled the points, so like x1, y1, x2, y2.
Mm-hmm.
And then I found the slope, so I did -5 minus 3 and over -1 minus 1. And I got -8 over -2, which just simplifies to 4.
Oh yes, nice, very good.
And then what I did was I plugged in the first point, so 1 and 3, into
Okay.
y mx plus b. So 3 equals 4 times 1 plus b.
Nice.
And then I just subtracted the 4 because 4 times 1 is 4. and I got -1 equals b.
Awesome.
And I just plugged that into y equals mx plus b.
Excellent. Thank you. So they put these pieces back together. We have b, we have m, and then the final equation is y is equal to 4x minus 1. You could also do this the other approach, just to remind you, once you find what m is, there's another approach that I showed you last time, which is actually really useful to know for calculus in general. That's the point slope form, where you essentially kind of say, okay, I don't know what y and x, if I want them to be on the line, I know that I'm going to calculate the slope from yx to, let's say, 1, 3. It better be true that the following equation holds true, that y minus 3 all over x minus 1 is equal to 4. So this is another way, this is called the point slope form. And if you expand it, multiply both sides by x minus 1 and rearrange and just solve for y, you'll actually get the same exact answer. So it's another approach. I think the solving for b approach is really nice. But this one will be useful later on as well. And remember what this represents is just saying that if I have another point, here's the point 3, 1. If I have another point xy somewhere on the line, could be anywhere on the line, then, and this is what, I should draw it rather like this. This is 3, 1. Oh, sorry, not 3, 1. 1, 1, 3, and this is -1, -5. Then we know that minus 3. Yeah, we know that in this case it's actually going to be this triangle here, y minus 3, x minus 1. We know that we get some sort of similar triangles when we compare the legs and we put a ratio. We can get we get similar triangles, and we get y minus 3 over x minus 1 equals 4 to 1. And one other comment, just with whenever you're doing this type of equation of a line, just do a quick sketch to make sure that your final answer makes sense. All right. Are there any questions on either of these? Okay. So today I wanted to go over a few more of these, just the last 3 questions from the diagnostic, and then maybe do that handshake activity that I talked about last time, because that's kind of a fun open-ended activity. But before we jump into that, how did you guys, I think the homework is due, I signed it for next week, but do you guys have any questions so far about any of the homework? Some people emailed me about the, like what pages it's on and stuff, so any questions on any of the problems? Mm-hmm.
So in total, it was only like 12, 13 problems, right? Because it was every other odd problem? Yes,
I think, but on each section, is that right?
Yeah.
Let me see. Yeah, I didn't want to overwhelm you because I really like this book, but there's a lot of problems. So, and again, with the homework, kind of, if you feel like you need practice and focus more on doing well on the earlier problems and doing problems carefully rather than rushing through them. So let me see, R1, how many problems are total? R1. Okay, yeah, so R1 has 24 problems. Somebody wrote there? Yeah. And I think was so, yeah, 24 problems, 94 divided by 4. Yeah, so that's a good amount of problems. If that's too many, like if you feel really comfortable with like some problems in R1, just feel free to skip them. Remember, I'm going to give you 100% of on homework if you turn something in. So really use homework for your benefit. +3 if you're. The way the way I'm going to ask for you guys to turn in homework is take a scan using Genius Scan or like a free scanner app. Email it to yourself and then upload the file when you submit the when you submit the assignment. You can upload. You have the option to upload a file with it. Yeah. Are there any actual questions about any of the problems? Olivia, you can take a picture, but if it's like multiple pages, I prefer the I just prefer a PDF because I think it's less memory and it a little bit easier to scroll through. Chapter 1, number 33. Yeah, let me take a look. Wait a second. Chapter. This is R1. So hang on. Wait, that's even though. Number 33, chapter 1. These are all in the back, by the way, the review sections. So R1, 33. This one is 2 plus -3 plus 7 plus 10. So you put all these pieces together. This is going to be -1 plus 7 is just going to be 6. So this comes out to 6 plus 10, and this will just be 60. Any other ones from either R1 or R2 or R3? 93? Konita, is that from R1? Okay, cool. So let's see this. International House of Pancakes contains, so this is 93. And also, as you like, one thing to definitely give priority to is skim the chapter. Make sure you feel comfortable with each type of example that they show you. And if you don't feel comfortable with an example, you can read. I really encourage students to read the chapters and examples multiple times. So one thing in math that's different than like English and history and maybe even science is like you don't have to expect to understand something on your first reading. You can, if you read it multiple times, like every time I read math, I need to read it at least like 4 or 5 times before I actually figure out what's going on. So just be patient when you have to read examples. Here, I think in these chapters is not super relevant, but it's really a really good way to study. And this book, I like how it breaks things down in a really, I think, clear and nice way. Yeah, Gabrielle, this homework starts on page, the sections start on page, they're the review sections. And they start on page 933. And it's the exercise sets. And this one starts, the R1 exercises start on page 938. Okay, so 93 asks, IHOP contains the strawberry, banana, French toast, contains 1060 calories. this is 20 more than 2 orders of McDonald's. The question is, how many calories in a McDonald's order? Okay, so this is a word problem, right? Any ideas, any thoughts, what variables we could introduce here? What would make sense and what's unknown? Nice, Archer. Yeah, we don't know the the McDonald's hotcakes. We don't know the caloric value of the hotcakes. So what could we introduce? What would be a nice thing to set up? Yeah, let's set up an equation. And before we set up an equation, this is one step I'm really going to kind of ask from you guys. Just define your variable. So let's say M is the calories. And don't just say, it's going to be really important to not just write McDonald's hotcakes, because later on in certain problems, we're going to deal with quantities that are multiple quantities that might be related to McDonald's. For example, if we're doing something about like the price of a pancake, we might have a problem that involves the quantity of pancakes, hotcakes that we sell, and also the price of each pancake, of each hotcake. So, so just be very specific. So M is the calories in McDonald's. Is it a, yeah, McDonald's hotcake. And that's almost, it's not even math there. We're just kind of writing an English sentence, but it's really nice to get us set up. Okay, and now we have to translate the actual information that they tell us into an equation. So what's a nice way to translate this into an equation? And what word should we focus on again? What's the most important 2-letter word? Nice, is. Archie, very good. So we're just, yeah, we focus on this word is. This I don't have to think about at all. That tells me that 1060 is 20 more than 2 orders. Or it has 20 more calories than 2 orders of the breakfast. So this is 20 plus 2 now. All right. Now let's try to solve this. Subtract 20 from both sides. You get 1040 equals 2m. And divide both sides by 2. Anyone want to type that into the chat? See what you guys got? See if you can do it without a calculator. Oh. Wait. For 93? Nice. Awesome. Yeah, it'll just be 520. Archer, wait, do I have the same? It says here, just ask how many calories are in the. Oh, I see. My bad. Yes. So actually, these last questions, I think if you struggled with number 93, yeah, thank you, Archer. I see. Translate each problem to an equation. Do not have to solve, and that's something that we'll also be doing later as well. Just setting things up. So extra practice, if you want to. I think some of the nicest problem to practice from this section are 89 to 94. So these are really worthwhile to practice. So this is a good practice for setting up word problems. Just all of them, if you feel like you need some more practice. Okay, thank you for asking that. That's a really good one to go over. Any other ones? R2, number 31. Okay. We're gonna do a bunch of this type of stuff. This is so R2 number 31. So we just need to solve, and here this is a nice one where there's not just one variable, there's 3 variables, but they want to solve for L. So the way to interpret that is we think of A and W as if they're just like whole numbers, or they're as if they're numbers, and we try to isolate L in the equation. So in this case, there's only one step. To get L completely by itself, in other words, to solve for L, you just divide both sides by W. This is going to be a useful technique sometimes when you want to solve a more complicated system of equations, or some sort of word problem, where you can replace an unknown quantity with maybe variables that are part of another equation, so you can eliminate using this unknown quantity. Okay, let's move on to, and I'll go over some more review questions next week as well. And if we have some more time, I'm happy to go over some at the end as well. Let's go back to the diagnostic and just finish these up. So let's do number 6. Was x squared plus 9x minus 36. So I think it's equal to 0. Yes. All right, so this, if you haven't seen this in a little while, you might not remember. But anyone volunteer how to set this one up and how to solve it? What's a good strategy? Nice. Arthur, yeah, very good. Yeah, you can try the, oh, nice, Amy. We will do complete, so we haven't done, we will do quadratic formula a little bit later in the class. So even if you know it, you're not quite allowed to use it just yet. And so the only types of questions I'll ask so far will be ones that you can actually factor. So if you remember, some of you might know the X method, where you have to think of 2 numbers that multiply to negative 36 and add up to 9. So what 2 numbers can you guys think of that satisfy this? Awesome. And what signs, Lily, what signs do we want on them? Perfect. We want 12 and negative 3. I encourage you, like X method is very good when you're kind of first learning how to factor, but hopefully you'll start, we'll do a bunch of quadratics, and I'll give you guys some more practice with these, but this is a good skill to just kind of, as you're practicing, to get good at just seeing the 2 numbers and kind of anticipating what they're going to be. So rewrite the equation here, leave some spaces, say, okay, 2 numbers that multiply to negative 36 and add up to 9. This is going to be plus 12 minus 3. Once I actually write it in my head, I will actually do the full multiplication out. I'm not going to write it all out, but I do like to just double check to make sure what I wrote down makes sense. So if you FOIL this out, you can double check that you get x squared. You also get the negative 36, that's the outside. And the, was it first? Outside, inside last, which one is that? Oh, I see, yes. That's actually not that's the last ones. So this is the first and the last ones are negative 36. And the middle one, you have you have 12x and then minus 3x for the two middle ones. And so you can verify that when you FOIL this out, it actually works. And now, because we have two quantities, two expressions that have to multiply to 0, that implies that either x minus 3 equals 0, or x plus 12 equals 0. And you can actually skip writing this step. I just like to write x is either equal to 3, because I think of the number that I can plug in to make the first expression 0, or x is equal to negative 12. But keep in mind that it does come from kind of setting each expression equal to 0, which is important when you know, it's not a simple x squared. Just for practice, I'm going to give you guys a few quadratics to factor. Message me privately if you are a little bit shaky on factoring. I just want to know who's not super comfortable. And we'll just do a quick drill right now of a bunch of quadratic factoring, okay? And then you can message me your answers. And I'll go through them. Let's see. Okay. So let's just go through these. And all of these, you know, usually, we'll see in a second why, but usually we are interested when these are equal to 0, and we try to solve these types of equations. Oh, I see. So it sounds like some students, you guys were learning this while coronavirus just hit, so you might not have actually gone to practice this very much. Okay, so try to think of this approach where first, before I ask about factoring, there is a really important skill that you need to be good at before you can do factoring, because factoring is the reverse of FOILing. So this is something really important. So make sure and message me if you felt a little shaky on this example, okay? Or if you feel comfortable with it also. So before you attempt these, let's do a little bit of FOILing as well. So FOILing, you know, it's just the idea of multiplying two expressions together, and you can think of it visually, or I just like to think that every pair that I can group from each parentheses, I multiply them together, and then I group all the results, and I group all the like terms. So if you're shaky on factoring, it's very important to be good first at foiling. And then I'll do here 2x plus 1 times x minus 3. Okay, so here's 1, 2, 3, 4, 5, 6, 7. 7 problems. I'll give you guys a few minutes to work on these. You can message me privately for any of them. Maybe I'll number them here. This will be number 1, number 2. We'll use another number. What's 1, 1, 2, 3, 4, 5, 6, 7. So please start with the FOIL and then go to the factoring ones. And let me look in the review sections. This is a really important skill that I really want everyone to be comfortable with. This is covered. Equations of line are really good. So this is covered in R5. So, and they go through a slightly more advanced version in R5. Later, we're going to do more complicated factoring where there's a number in front of the x squared. But for now, just the regular x squared is something that we'll work with. Yeah. Oh, Allison. Yes, you can send me your answers as you get them, or when if you want, you can towards the end. And I'll go over all of them. I'm going to post the solutions. But if you just want to get some feedback right away, feel free to send them. Let me see here. Nice, Ronnie. Yeah, if I see you got the right one, I'll just give you a thumbs up and just say your name. Ronnie, excellent. Lupe, yeah, two. Lupe, nicely done. Nice. Emily, very well, very good. Jimenez, yes, well done. We're on X1 factoring. No worries, no worries. Okay, let's see. What numbers go on the X when factoring? Oh, okay. You mean, Amy, were you asking about the X method there? Okay, gotcha. So the number in the X method is the number in the top is usually people put the last one. This is the product or the last one in the quadratic. The last number, it's the constant. And the number below it, people put the middle number. It's the coefficient of X. So I'll just color it in here. This is the one that we put in the bottom, and this is the one we put with the sign. You're always going to include the sign as well. Okay, very good. I see a lot of you. Charlie, well done. Archer looks good. Nice. All right, so I'm just going to go through them here. First, I'm going to start with foiling, and please just hit the space bar and jump in if you have any questions, because I'm going to move a little bit quickly through it. So let's foil this together. The first thing I would see here for number 5 is first I have x times x, so that's what I do first. Oops. So I have x squared. And then I look at the middle terms, and I anticipate, based on how I know foiling works, that those are going to get combined. So I have 3 times x, and I also have minus 7 times x. And here the numbers are fairly small, so I'm not going to spend all the time writing everything out. I'm just going to think in my head, okay, 3x and negative 7x, how many x do I have? Oh, I see. Yeah, I saw Mason in the Uber or something. Okay, so I'm going to think, how many x do I have if I combine 3x and negative 7x? How many x will I have? Minus 4x. And then the last one is just the two numbers multiplied. So this way I got every single pair that I possibly could. The middle two pairs combined because they all have 1x. And that's the main idea with foiling. With factoring, we try to kind of play a game where we undo the foiling process and we try to piece together, okay, what two numbers could multiply to the last one, and what two numbers, which of those numbers could add to the middle one. Okay, and here we have, again, foiling it out, you get x squared, and then plus 4x minus 6x. So if I do these two and these two, that will be minus 2x. And then the last one here will be minus 24. And if you think I make an error, because it's very likely for me to make an error, just jump in and ask, hey, Mr. Minsky, I got something different from you did. Okay. And anyone want to go through, volunteer, how to do number 7 here?
Sure, I can.
Yeah, go for it, Elson.
Okay, so I distributed 2x into x minus 3 first.
Mm-hmm.
Got 2x squared minus 6x. Yeah. And then I then distributed the negative 1 into x minus 3, and then got x minus 3, and then I combined the like terms.
Nice. Yeah, and just I think the plus 1 here. So
Yeah.
it'd be plus 1 plus x minus 3, because it just becomes that. Awesome, and then it all combines. So 2x squared plus, oh, sorry, not plus, minus 5x.
Yeah, minus 5x minus 3.
Awesome, thank you. Okay, very good. We're going to do a little bit later on, we're going to do factoring of terms that have a number in front of the x squared. That's just a little bit more complicated, but the foundation really is just how to factor when it's just a regular x squared. Because if you know how to do that, you can factor anything. And keep in mind, this factoring method, it really is a game of guess and check. You're trying to use your comfort with kind of knowing the factors of the last number and seeing which of those factors could add up, which pairs of factors could add up to the middle number. And it doesn't always work. It's not always possible. Okay, so for this one here, for number 1, which two numbers multiply to 6 but add up to 5, positive 5? And the signs are always very important. So here it's going to be x plus 2 and x plus 3. And don't just like think that, yo, I figured out some numbers that work and just move on. Actually, quickly in your head, FOIL this out just to verify that you get what you were supposed to get, because that'll help you avoid mistakes. And this implies the numbers that you can plug in to make it 0 are x equals negative 2. Oops. X equals negative 2, or x equals negative 3. How about this one? Can anyone tell me just really quickly how they factored this one? Number 2? So two numbers that multiply to 4, but they add up to negative 5. It's a little bit of a weirder one.
Negative 4, negative 1.
Nice, thank you. So it's going to be x minus 4 and x minus 1. Yeah, the ones where the middle number is negative, there's a few possibilities, right? You can either have, the ones where the middle number is negative and the last number is positive, that can only happen if both of them are negative. So that's a kind of a nice thing to think about. And then this tells us that, okay, our solutions are x equals 4 or x equals 1. How about number 3?
For number 3, I got negative 8 and 2.
Awesome. X minus 8, and then x plus 2. And I'm going to really push you guys to actually, every time you solve one of these, actually write the factors out and then write the numbers so that you don't get confused. A lot of times, like, I've made this mistake as well. I get excited that I figured out like how it factors, and then I'll just write, okay, x equals negative 8, x equals positive 2. I don't do that extra step of, okay, now I need to think about what actually makes that equal to 0. So then it would be x is equal to 8, and x is equal to negative 2. Please message me in chat if you're not sure why it's x minus 8, or if you have any questions about 1, 2, or 3. Does anyone have any questions about any of them? You can message me privately, and I'm happy to explain. Because we are going pretty quickly through this. Oh, okay. Emily asked a really, really good question. Do you just flip the sign? You do just flip the sign. In this case, it works out to flipping the sign. But I don't want you to think of that as what's actually happening. I really want you to think about solving this expression, setting this expression equal to 0. Because, for example, if you get an expression like this and you factor it, and you want it to be equal to 0, the solution is not just negative 1. It's actually going to be 2x plus 1 is equal to 0. And if you solve this, you get 2x is equal to negative 1, or in other words, x is equal to negative 1/2. So there's all sorts of weird ways that you can kind of trick somebody up if they just think about the rule, oh, whatever thing you have in the expression, just change the sign. For example, if I have this expression, 8 minus x times times x minus 5 equals to 0, if you're just thinking about flipping the sign, you might say, oh, okay, I know this answer. It's going to be x equals 5 and x equals negative 8. But do you see why that's not going to work? And why it's kind of like a little bit of a trap for some students? So the real answer here is x equals 5 and also x equals 8. And yeah, so that's why I hesitate about just teaching to flip the sign. Okay, and then the last one is going to be what two numbers multiply to 9 but add up to negative 6?
X, negative 3.
Nice. X minus 3, and then another x minus 3. And this is something we call a perfect square because it's the same expression times itself. And we're going to do a bunch of stuff later with perfect squares. And I think one of you mentioned the technique of completing the square. So we're going to see a bunch of that later. So this is x equals 3, and there's only one solution. All right, well done. So any questions on any of these? Please hit a yes, smash the yes button if you feel a little bit more comfortable now with factoring and foiling. Smash the no button if you feel like maybe you need a little more practice or cool. I'm glad that you guys are pretty comfortable with this. All right, let's move on to where was it here? Okay. So let's move on to this one. Number 7 and 8. So let me copy and paste. Actually, you know what? Yeah, I'll copy. Okay, so try this one out, and I'm gonna, while you're working on this one, I'll give you guys a few minutes to just write this on your paper. And then I'm gonna also bring down the other one. Okay. So I'll give you guys a few minutes to think about this one. And message me if you need a little assistance or you're a little bit stuck on how to set it up. Or if you think you got it or you got the first equation, You're welcome to message me at any point. Oh, and here's the second one too. I'll bring it up. Archer, nice equation. I like that. Oh, actually, so I see some. Yeah, you guys are giving me some great comments. Okay, let's see here. And a nice hint is once you have an equation set up, see if you can apply what we just worked on with quadratics to solve it. So if you're having some trouble setting up the equation, just start. A good problem-solving strategy is start with like start writing down some things that you know for sure. Like what are some relations and things that you can say that, okay, I know this means this. You don't need to see the whole problem right away. Ah, okay. And I saw a few students make this mistake, and this is actually really, this is one that they'd like to throw on the SAT. Be careful of questions that ask for area versus questions that talk about perimeter. Right? And last class we did a problem where they talk about the perimeter. Here they talk about the area. So the area is the product of the height and width, and then the perimeter, is the sum of 2 times the height and width. So just be careful. Always read that carefully. It's easy to skip area versus perimeter. Um, okay, so here, yes, the square feet is a hint that it's about area, and also it's mentioned too. So most of these problems, they'll be very explicit, like, do you want the area or do you want the perimeter? Okay, so let me see here. And I'll always try to get some volunteers to explain. Um, but if I ever ask you, never feel any pressure. You're always welcome to decline, because I know it can just feel weird to be in the Zoom room. But I definitely like when other students um, are willing to share kind of how they did problems. It's very, and I think it's important also for me to see how you're thinking through problems and how you're working through them. I get a lot of that in the in-person class, but in the Zoom class, it's harder for me to see that. Anyone want to volunteer to explain how they set up number 7? And you can also, if you have a mouse or if you have a stylus, do you guys know this? You can actually share your, if you have another iPad or a phone, you can actually share your screen. Yeah, you can actually share your screen and you can annotate on that screen. That's how I share with my iPad. I hit share and then start sharing through AirPlay. And you can also, as well, if you're on an iPad with the Zoom lesson, you can annotate on through here or with your mouse. Any volunteers to that want to explain number 7?
I can do it.
Yeah, go for it.
Go,
Okay. Oh wait, is it both Allisons?
Either one.
Who's going? Okay, I'll go. So what I first did was I did W equal width equals height minus 5, but then like height and width equals 36. So then I just plugged in, so I did H parentheses H minus 5 equals 36. Then I factored that H into the parentheses and I got H squared minus 5H minus 36. And then I did like the magic X thing, and then I got H plus 4 and H minus 9, but then I like switched the signs and I got H equals negative 4 and H equals 9, but because it's negative, I just assumed it was impossible, so I got H equals 9.
Awesome, thank you, Allison. That's perfect. So yeah, we expanded, and here you say, oh, I have a quadratic. I know a technique to solve quadratic. It's going to be factoring. So then We move it over, we factor, and what is this? What two numbers multiply to 36, but at negative 36, but add up to negative 5? The bigger one is going to be one of them has to be negative, and because the middle number is negative, that means that's going to be the bigger number, so it's negative 9, and then h plus 4 equals 0. We have two answers, h equals 9, or h equals negative 4, and this doesn't make sense because we want it to be a height, so we have the height equals 9, and then you just check that the width would equal to 4, and does it work out? Yeah, it does. Okay. Very good. Thank you, Allison, for volunteering. I appreciate that. So, are there any questions on this? Okay. Last one here. So this is combining expressions with different denominators. We did a little bit of this with numbers, but what's the main idea when you add up two numbers like this, like 2/3 plus, 3/7? What do you have to do here? What's the main idea?
Common denominator.
Common denominator, exactly. So with algebra, it's the same thing. We can't add up like 1 over x minus 3 and something over x minus 5. We have to make them both look the same. So we do the same thing that, here, sometimes you find the least common multiple of them, or that you don't always want to make the denominator, like, you could have just multiply them by the same number so that you get like multiply them by each other to make them the same, but sometimes you get the least common multiple. And with algebra, it's pretty much the same idea. So here we wanted everything to be 21 in the denominator, and then what did you get? 14 plus 9 all over the same denominator. And the 14 plus 9 is 23 over 21. So that's its own little problem there, just kind of little motivation. But here we'll just multiply by the number 1 to change the, not x minus 3, but x minus 5 all over x minus 5. So I'm not really changing this fraction, I'm just changing what it looks like. Just like over here, when I multiply by 7 over 7 and I turn it into 14 over 21, 14 over 21 is still 2/3. But it just looks different. So I'm not doing any math really, I'm not solving anything. I'm just changing up how it looks. And over here I multiply by x minus 3 all over x minus 3. This is not cross multiplying because we don't even have an equation. We're just rewriting things and we're combining two rational expressions. These are called rational expressions because they have an x on the top and the bottom of the expression. It's called a rational expression. And we're combining them into an expression with just one denominator. Okay, so now we can do some foiling. Remember, important thing here is when you do this approach, you have to remember to FOIL. So the first expression we have x squared minus 5x plus x. So if I do that, then I'm going to tell myself, oh, I have minus 4x, and then it's minus 5, plus, and I'll maybe put this in parentheses here, x squared plus 5x minus 3, that's going to be plus 2x minus 15. And on the bottom, I have x minus 5 times x minus 3. And I know that that's going to come out to be x squared. And then minus 5x minus 3x, that's going to be minus 8x plus 15. And now I got to put together all the pieces in the numerator. So what I have in the numerator will be x squared plus x squared, like terms. So that's 2x squared. Minus 4x plus 2x will be minus 2x. Minus 5 minus 15 will be minus 20. And in the denominator, I just have this other term, x squared minus 8x plus 15. Okay. Any questions? Give me a yes if you're comfortable with that, or just message me if you have any questions. Sweet. Okay. Thank you, guys. Very good. Oh, can we go in more in depth? What between a yes and no? Okay, very good. As in simplified. Oh, no. This you leave your answer like this. There's no more. There is another thing you can do further here, but this is as far as kind of I'd want you to go here. Brandon, let me see, number 7. Yes, let me just show number 7 here. Okay, so the last 10 minutes, I just want to go through this little exercise, and maybe we'll just spend the last part of the class talking a little bit about it, and we can discuss the beginning of next class as well. So I usually like to do this activity that I call like the handshake exercise as an icebreaker on the first day of class, but we couldn't really do it because of coronavirus. But what I usually ask students to do on the first day of class is to stand up and go around the room and introduce yourselves to each other. Let me see here. Lily asked a good question about factoring this. You could factor the denominator because that came from x minus 3, x minus 5. But the numerator, I believe that one doesn't factor nicely because, be careful here, when you take out the 2, this will be 2x squared. You have to take out the 2 from everything. So it turns out that this expression doesn't factor anymore. I think you just didn't factor out the 2 from there. Okay, so I asked students to go around and shake each other's hands, introduce themselves to each other, and what I asked each student to do is to keep track of how many hands that they shook. What we do is I then kind of go around the class and I ask everybody how many hands did you shake, and I show you something a little bit surprising that will always hold true no matter how people decide to shake hands or how many hands they decide to shake. So no matter how, even how many students there are. And because we can't do that in person, we can instead model it with an abstraction that's actually a really important part of math. So what we're going to do is, instead of like actual students, we're just going to have little dots here. So let's say we have 5 students. Of course, you can draw as many students as you want. And keep this drawing in mind because I'll encourage you over the weekend to see if you can draw some more of these pictures, maybe with 6 students, or maybe with 9 students, or 10 students, or 11, however many you want. Here's Alice, Bob, Cindy, Dan, and Evan. And then I'm going to make them shake hands. And to represent a handshake, what I'm going to draw is a blue edge between a pair of students. So can anyone just in the chat, or you can say it publicly, just give me which 2 students you want to shake hands. So you can say like AB or BD. Okay, AB. So we got AB in here. AC. Let's just do a few of them. AC. We already have AB, and then BE. Okay, cool. And let's do one more. DA. Okay, cool. Nice. Oh, you guys picked the same one at the same time. I like it. Okay, great. So this is just some random configuration. Cindy and Dan didn't get to shake hands. Um, Alice and Evan didn't get to shake hands. Dan and Evan didn't get to shake hands, but the other pairs did. So what we're going to do is we're going to make a little table. I'm going to write Alice, Bob, Cindy, Dan, and Evan. And what I'm going to say is what I would usually ask is I say, hey, Alice, tell us something about yourself. This is the first day of class. And how many hands did you shake during the exercise? So what would Alice say here? How many students did Alice shake hands with? Not two. She shook hands with Bob, Cindy, and Dan. So she got three. Nice. Yeah, so she got three. And then Bob did shake hands with two people. Cindy shook hands with one person. Dan shook hands with one person. And Evan shook hands with one person. So this is it. This is called the number 3, the number 2, and so forth. Well, first let me kind of tell you what the mathematical name for this is. This is called a graph. And this is part of a branch of math called graph theory. And graph theory is a way to abstract situations where you want to have objects and you want to model the connections between different objects. And not everything is connected, and some things are connected. So the people here are called the vertices. They're like the dots or vertices. They're the set of points, so they represent the people. And the handshakes are called, the mathematical term for them are just edges, so they could be the handshakes. And the degree of a vertex is equal to the number of handshakes that V had. Okay, so all we did here is the degree of the vertex of each vertex. So just the number of handshakes that each one had. By the way, does anyone know how this is actually used in your everyday life? Like what technology uses this sort of mathematics a lot? It's something that we use almost every day, unfortunately. Does anyone see how? Oh, Lily, nice. What part of our phones could graph theory be related to? What part of technology? And there's actually a lot of answers here. Nice, Archer. Social media. Texting is one. Yeah, yes, so there's a lot of examples. This is a really general abstract structure and way of thinking about things that could be applied to a lot of different things. The most obvious example that kind of relates to what we did here is Facebook, right? The individual people are the vertices, and the friendships you have between people are like the edges. And so you can get all these different networks, people who are connected to each other, and you can say, oh, I'm a few degrees away from somebody else. And so studying graphs and their property is a really big thing that Facebook does. Another interesting thing that you might not have thought of is the internet itself. The web pages also form a graph. Does anyone know how they form a graph? Anyone want to take a guess, a stab at that one? So how could web pages and the internet in general have vertices and edges. Okay. Nice, Archer, very good. Yeah, so web pages are, could be like the vertices, and each web page has links to like the home page, to another source page, or to another like page, or reference or whatever. And so that forms a graph where the links between two web pages are an edge, and the web page itself are the vertices. So there's lots of different ways to apply this to real life. And one of the reasons Google became so successful was because they started thinking about the web as just a big graph. And they gave you results that didn't just have like Yahoo first gave, like this is back in the late 90s, early 2000s. They didn't just give you like a page that had a lot of keywords, because that could be easily spammed. They figured out that the most valuable pages were the ones that had the keywords that you were looking for, but also had a lot of references and links to them. So they looked at kind of valuable parts of the entire graph. And that's why whenever you search a concept nowadays, Wikipedia is one of the first search results that you'll get, because anytime somebody writes about some topic, they'll usually reference Wikipedia, and that really increases the value of Wikipedia in the graph. So that's kind of an example of why Google is so good. Okay, so I'll let you guys go after this. I'm just going to tell you the statement of this result of the theorem, and I'm going to leave you over the weekend just to think about it, and we'll come back on Monday, and we'll talk about it a little bit again. So here's the statement. No matter how many people there are, no matter how they shake hands, the following statement will always be true. So the number of students who shook hands an odd number of times is even. So this is our theorem, and the challenge for homework is, can you think about why this is true? And maybe on Monday, Monday no school, great. Tuesday, have a great holiday on Monday, and then on Tuesday, thank you, we will go over it on Tuesday. Yeah, the number of students who shook hands an odd number of times is even. That's a bit of a mouthful, but let's just try it for this example. So which students shook hands an odd number of times? So who shook hands an odd number of times? Did Alice shook hands an odd number of times? Yes. Alice shook hands 3 times. Bob shook hands twice. That's the even number, so that one doesn't count. Cindy shook hands once, which is also odd. Dan shook hands once, and Evan shook hands once. So the total number of students who shook hands an odd number of times is 4. And is that an even number? It is. So the theorem is that no matter how many students, no matter how they shake hands, that if you circle the ones who shook hands an odd number of times, you're always going to get an even number of them. So I encourage you for homework at least to try to explain this. And if you're stuck with explaining it, a really good way to approach a problem that you don't know how to solve is, hey, let me try a few cases. So maybe draw like 7 people and just draw some random edges and just have fun and see if it's always true. Maybe it's not always true. So explore a little bit. If you like this type of idea, this is not like there's no equation to solve. It's just exploring and seeing what you can come up with. So I'm really excited to see what you guys come up with on Tuesday. All right, Graydon, there will be the same Zoom. Everything is the same as next week. Just no class on Monday. All right, guys. I hope you have a wonderful 3-day weekend, and I'll see you guys on Tuesday. Well done. See you guys. Thank you, Amy.